Ever wondered how your email filters out spam or how Netflix recommends movies you might like? These are examples of machine learning at work. Machine learning, often abbreviated as ML, is a dynamic subfield of artificial intelligence. It's the science that empowers computers to learn and improve without explicit programming. Imagine a child learning to identify animals. You don't program their brain with a set of rules. Instead, they learn by observing, making mistakes, and correcting those mistakes. Similarly, machine learning algorithms learn from data, recognize patterns, make predictions, and adapt to new information. Now, why should we care about machine learning? Because it's revolutionizing various industries and aspects of our lives. Let's take a look at some examples. In the world of entertainment, platforms like Netflix use machine learning for personalized recommendations. They analyze your watching history, compare it with millions of other users, and suggest what you might enjoy next. In healthcare, machine learning aids in medical diagnosis. Algorithms are trained to scan medical images and detect early signs of diseases that might be hard for the human eye to catch. In finance, machine learning is a key player in fraud detection. It can analyze millions of transactions in real time, flagging any suspicious activity that deviates from the norm. And let's not forget about the automotive industry. Self-driving cars are no longer a sci-fi dream, but a reality, thanks to machine learning. These cars are trained to navigate roads, recognize traffic signs, and avoid obstacles, all while ensuring a smooth ride. So that's machine learning for you. In a nutshell, it's a technology that learns from data to make our lives easier, safer, and more enjoyable. But how does it do this? What's happening behind the scenes that transforms raw data into meaningful insights? So, what are the key components that make machine learning work? Let's dive in. The magic of machine learning lies in a few core components: data, algorithms, model training, evaluation, and prediction. Let's start with data, the bedrock of machine learning. Whether it's structured like tables and numerical values, or unstructured like text, images, and videos, the quality and relevancy of data are paramount. More data equates to better learning and performance for our algorithms. Speaking of algorithms, these are the mathematical and statistical techniques that make sense of the data. They come in three main flavors: supervised learning, unsupervised learning, and reinforcement learning. Picture supervised learning as a teacher-student scenario, where the algorithm learns from provided input-output pairs, like a student learning from a teacher. It's great for tasks like spam filtering or predicting house prices. Unsupervised learning, on the other hand, is like an explorer discovering hidden structures in uncharted territory. There's no teacher to guide the algorithm, so it finds patterns in unlabeled data. This is handy for things like grouping customers by behavior or compressing data for efficiency. Reinforcement learning is the adventurous one. It learns through trial and error, interacting with an environment, and receiving rewards for desired behavior. Think of a video game player learning to navigate a new game. It's used in areas like game playing and robot control. Next up, model training. This is where the raw data is used to adjust the algorithm's parameters, essentially teaching it the desired behavior. We use optimization techniques like gradient descent to minimize the gap between the algorithm's predictions and the real values. After training comes evaluation. We test the model's performance on unseen data using metrics like accuracy, precision, recall, and F1 score. It's like report card day at school. This helps us gauge the model's generalizability and identify areas for improvement. Finally, we have prediction or decision-making. This is when the trained model gets to work on real-world data. For example, a spam filter might classify an incoming email as spam or not spam based on what it has learned. Knowing these components, we can now explore the different types of problems that machine learning can solve. Machine learning is a versatile tool, capable of solving a variety of problems. Let's delve into the different types of problems machine learning can tackle. First up is classification. This involves sorting data points into predefined categories. Think of your email's spam filter, distinguishing between spam and non-spam messages. Next is regression. This is all about predicting continuous values based on input features. For instance, predicting a house price based on factors like size and location. Then we have clustering. This is the process of grouping similar data points together without predefined categories. It's like grouping customers by their buying behaviors for targeted marketing. Dimensionality reduction is another interesting problem. It involves compressing high-dimensional data into a lower-dimensional space, preserving essential information, making data more manageable and comprehensible. And finally, recommendation systems. These suggest items or content a user might like based on their past preferences and behavior. Think about your favorite streaming service recommending what to watch next. So, machine learning can solve a wide range of problems, but what are the benefits of using it? Machine learning has the power to transform organizations and industries. But how exactly does it do this? Let's take a closer look at some of the benefits that machine learning brings to the table. First up, automation. Machine learning algorithms can handle repetitive and time-consuming tasks, freeing up our time to focus on more strategic and creative endeavors. From sorting emails to processing large amounts of data, machine learning is a productivity powerhouse, enhancing efficiency and accuracy. Next, let's talk about decision-making. In a world overloaded with data, making sense of it all can be a daunting task. This is where machine learning shines. It can analyze vast amounts of data, identify patterns, and provide actionable insights, leading to better informed, data-driven decisions. Whether it's a business trying to identify new market opportunities or a healthcare professional diagnosing a patient, machine learning can improve the decision-making process significantly. Personalization is another key benefit of machine learning. It has the capacity to tailor experiences to individual needs and preferences. You know those product recommendations on your favorite shopping site or the For You playlist on your music app? That's machine learning at work, learning from your behavior and preferences to curate a personalized experience just for you. The predictive power of machine learning is truly remarkable. It can forecast future trends and events based on historical data, enabling proactive planning and risk mitigation. This can range from predicting stock market trends to anticipating customer behavior and even forecasting weather patterns. Lastly, scalability. Machine learning algorithms can analyze and learn from large data sets that would be impossible for humans to process manually. As data grows, so does the learning potential of the machine. This scalability makes machine learning a valuable tool in our data-driven world. Machine learning, thus, is a powerful tool with far-reaching implications. It is changing the way we live, work, and interact with the world. From automating tasks and improving decision-making processes to personalizing experiences and predicting future trends, machine learning is revolutionizing our world in countless ways.